In 1928, Walter P. Chrysler stood on a vacant Manhattan lot and decided to build the world's tallest building in 19 months. He had $15 million, a competitor building 3 blocks away, and a design that wasn't originally meant to be that tall. When his building opened on May 27, 1930, it wasn't just the tallest structure on Earth. It proved that impossible timelines could actually be met under conditions that would challenge modern project management. This is how it was actually built. I went through construction archives and historical documentation of unprecedented detail. Then I used AI to reconstruct what the work actually looked like on the ground, filling gaps where historical records were incomplete or lost to time. This is the untold story of the race for the sky. From the first excavation through months of relentless construction, to the moment the stainless steel spire crowned the building as the world's supreme achievement. If you like construction history and enjoy this video, hit the like and subscribe button. In 1928, Walter P. Chrysler purchased the Lexington Avenue property and decided to build the world's tallest building. The original plan, designed by architect William Van Allen, called for an 808-foot tower, impressive but not unprecedented. Then he learned the Bank of Manhattan was competing for the same title. That's when Chrysler changed the plan. He would build higher than anyone thought possible. On September 19, 1928, groundbreaking took place. And here's the thing that strikes me about early skyscraper construction. The press understood immediately this was a race. The New York Times published updates. Radio stations tracked progress daily. Every week brought new headlines about which building was winning. The site was nightmarish. Manhattan bedrock required digging 45 feet down to reach solid ground. In November 1928, excavation crews began what would become a staggering demolition of Manhattan's subsurface. Crews removed over 36 million pounds of soil and more than 100 million pounds of rock using compressed air hammers, jackhammers, and manual labor. No mechanized excavators existed. Men worked rotating shifts day and night because the schedule allowed no downtime. The excavation lasted through January 1929. In March 1929, with foundations complete, Fred T. Lay and Company hoisted structural steel. Engineer Ralph Squire and Sons had designed a riveted steel frame that pushed precision beyond what was possible in 1928. And here's where I need to acknowledge the engineering. Riveted steel construction was a craft, not a science. Riveting teams worked in crews of 4, a riveter, a helper, a bucker, and a catcher. Each rivet was heated in a forge, driven through pre-drilled holes while hot, and bucked on the opposite side. The precision required was staggering. Every rivet had to be perfect. If a single rivet failed, the entire assembly was compromised. Contemporary photographs show riveting crews suspended from cables, working hundreds of feet above the street. The construction pace was savage, 4 complete floors every single week. This was the fastest vertical construction ever attempted in American history. The Bank of Manhattan was being surpassed in real time, floor by floor. The public watched the race unfold week by week through newspaper updates and radio reports. This was construction as public spectacle, unprecedented in scale. But Chrysler had a secret that would change the entire outcome. Architect Van Allen had obtained difficult permission to build a 125-foot stainless steel spire hidden inside the building frame during construction. Nobody outside the inner circle knew it was coming. It was an ace being held in reserve. While everyone watched the public height race unfold, Chrysler and Van Allen were secretly building something that would make all public measurements irrelevant. On October 23, 1929, the spire sections arrived at the site under extraordinary secrecy. Hoisted in 4 separate pieces, the stainless steel crown was assembled on top of the building like a magician's final trick at the climax of a show. When lowered onto the 66th floor, the Chrysler Building's total height became 1,046 feet, surpassing the Bank of Manhattan's 927-foot tower. The press erupted with headlines dominating front pages. Newspapers that had been tracking the race suddenly realized the competition was over. Chrysler had won by almost 120 feet, rendering further competition pointless. The building officially became the world's tallest structure in October 1929. Height had been redefined under a construction timeline nobody thought achievable. Every construction expert, every engineer, every builder understood that something fundamental had changed in the industry. The stock market crashed a week later, on October 29, 1929, sending shockwaves through the American economy. But the Chrysler Building's supremacy had already been secured, locked into place by the spire that had been hidden all along. While the structural steel rose, an equally complex thing was unfolding on the building's exterior. The facade wasn't simply brick and mortar applied to a frame. It was a carefully orchestrated integration of materials, systems, and artistic vision that had to happen simultaneously with the steelwork. The distinctive Art Deco crown was assembled piece by piece as the building rose. The crown sections featured triangular windows arranged in a sunburst pattern. Each one was precisely manufactured and fitted. The stainless steel cladding on these crown sections reflected light differently depending on the time of day and weather, creating an optical effect that made the building seem to change personality throughout the day. The reflective quality of the stainless steel created a shimmering effect that caught sunlight at different angles. The facade materials were extraordinary for 1930. The primary exterior used approximately 3.8 million bricks, nearly all laid by hand. But bricks alone wouldn't suffice for a building of this ambition. At strategic points, the architects introduced Nirosta stainless steel, a relatively new material at the time. This steel didn't rust, didn't corrode, and didn't require maintenance. The window frames, corner accents, and ornamental elements used this material, making the building shine with a metallic brilliance that caught the eye of anyone approaching from any direction. The spire sections featured a distinctive pattern of horizontal lines and triangular windows that created an optical rhythm as your eye moved upward. By May 1930, when construction finished, the completed facade revealed Walter Chrysler's vision in full. The building wasn't just tall, it was a vertical sculpture. The lower sections, clad in brick and limestone, provided solid grounding. The middle sections stepped back progressively, creating a sense of ascension. The upper tiers became increasingly metallic, with stainless steel catching light and drawing the eye upward. Finally, the crown, that stunning spire with its geometric window pattern, pierced the sky like a needle, simultaneously elegant and aggressive. The building's exterior was designed to be seen from every angle. Looking north from 42nd Street, the stepped profile created a pyramid-like silhouette. From the east or west, the stainless steel crown dominated views for blocks. From the south, the building's mass seemed to grow lighter and more ethereal as the eye traveled upward, the brick giving way to steel, the steel giving way to the gleaming spire. No contemporary photograph or architect's rendering had prepared New Yorkers for the actual visual impact of the completed structure. By November 1929, with the spire crowned, the real construction challenge began. The building had to function as a complete vertical system with technologies never tested at this scale. What the press saw as triumph, workers on site experienced as sustained challenge. Here's the thing about building the world's tallest building. You're not just building higher, you're solving every single construction problem simultaneously at a height where mistakes are exponentially more dangerous. They had to install 32 elevators stacked 77 stories high, with mechanical precision only possible through calculated redundancy. Each shaft had to be perfectly plumb and aligned, or the entire system would fail. The mechanical systems, engines, hydraulics, cables, had to function flawlessly at height. Westinghouse supplied electric motors rated for continuous service. The cable systems used steel wire rope manufactured to exact specifications. Any flaw in the cable would be catastrophic. The brickwork required approximately 3.8 million bricks, nearly all laid by hand during Manhattan winters. The mortar was mixed with heated water to prevent freezing. Bricks were heated before laying, so temperature changes wouldn't crack them. This was coordinated manufacturing scaled vertically, with supply lines constantly flowing upward. Bricklayers worked in teams moving up the building as it rose, with heated materials constantly being delivered. And here's what I find fascinating. The construction reports describe controlled chaos that never fell apart. Simultaneous construction workflows made this possible. While concrete was poured on one floor, steel was erected above, brickwork happened below, and elevator mechanics were installed further down. The contractor Fred T. Lay and Company managed operations that should have tangled into disaster, but somehow held together through relentless attention to detail and radio-coordinated crews working across different floors at different elevations. This was one of the first buildings where radios coordinated multiple work crews across different heights and floors simultaneously. Workers were a mix of skilled tradesmen from across America, iron workers from Pittsburgh steel mills, electricians from other buildings, bricklayers from Philadelphia, because there weren't enough skilled workers in New York. Coordinating thousands of workers up and down a building growing taller every week meant the construction site itself became a vertical city with supply chains, crew rotations, and logistics problems rivaling Army coordination. November 1929 through May 1930 was one continuous sprint. By May 1930, the building was complete. The Cloud Club on the 66th to 68th floors was being finished for Manhattan's elite. Tenants had committed to $583,000 annually. The economic confidence was absolute. On May 27, 1930, the Chrysler Building officially opened to the public. Construction from groundbreaking to opening took less than 2 years, a staggering achievement for a 1,046-foot building with 77 stories. In 1930, with that era's technology, this represented something between engineering triumph and organizational miracle. The official opening was treated as a civic ceremony on an unprecedented scale. The 42nd Street Property Owners and Merchants Association hosted the dedication. Guests were escorted to the observation deck, where they could see the entire Manhattan skyline spread beneath them. They were standing higher than the Woolworth Building, which had held the title of world's tallest for 17 years. They were standing higher than any human had ever stood before. The architecture embodied Art Deco, the design movement defining 1920s to 1930s optimism and modernity. The distinctive setback design served both aesthetic and functional purposes, reducing wind stress, distributing loads differently across the frame, and creating visual drama. The interior was equally revolutionary. The lobby featured Art Deco murals, elevator doors inlaid with wood and metal, and lighting fixtures designed specifically for the space. But here's what strikes me going through the construction documents. This building demonstrated that tight schedules don't require cutting corners. When the Empire State Building opened in 1931, just 1 year later, it surpassed the Chrysler Building at 1,454 feet. Yet the template for how to achieve such ambitious goals had been established. The methods that made the Chrysler Building possible became the foundation for everything that followed. The structural systems, the scheduling techniques, and the modular thinking became how complex buildings are constructed worldwide. When Willis Tower rose in Chicago in the 1970s, when modern super-tall buildings rise today in Dubai, Singapore, Toronto, and Shanghai, they follow principles established on a Manhattan lot in 1928 to 1930. The building held the world's tallest title for almost 339 days, from May 27, 1930 to May 1, 1931. That single year proved Walter Chrysler's fundamental thesis. Height isn't about distance. Height is about how you manage thousands of people under deadline pressure, solve multiple problems simultaneously, and maintain standards. The building required 0 worker deaths during construction. In the 1920s to 1930s, construction fatalities were routine. The Chrysler Building achieved this zero fatality record because every worker, every task, every material movement was precisely planned. When systems are planned that meticulously, accidents that would normally kill workers simply don't occur at the same rate. Safety protocols were developed. Crew training was standardized. Protective equipment was provided before it became standard industry practice. No monuments were erected to the workers who constructed this building. No plaques acknowledge the ironworkers, bricklayers, crane operators, electricians, and plumbers. But every technique they pioneered that included workflow systems, logistics planning, crew scheduling became the infrastructure modern construction depends on. Today, Tishman Spire owns the building. It was designated a National Historic Landmark in 1976. 3,000 office workers arrive daily, likely unaware they're in a structure representing one of the most remarkable construction achievements in human history. The riveted steel frame, stainless steel crown, and 3.8 million bricks remain standing, still supporting millions of square feet of office space. The building remains a UNESCO World Heritage candidate and architectural priority in New York City. What the Chrysler Building accomplished in 19 months was something no construction historian expected. Not just a building, but a proving ground for coordinated human effort under pressure. The building stands today as proof that precision at scale can be achieved under circumstances that would break most modern organizations. The race between Walter Chrysler and the Bank of Manhattan wasn't just about height. It was about proving that speed and safety weren't mutually exclusive, that human organization could overcome seemingly insurmountable obstacles. That ambition, when properly channeled through systems and planning, could achieve what appeared impossible. Walter P. Chrysler didn't just want to build the tallest building. He wanted to build it faster than anyone thought possible. He succeeded, and in doing so, created a template not just for his building, but for how all ambitious construction projects would be managed for decades to come. The workers, the bricklayers who laid 3.8 million bricks in Manhattan winters, the ironworkers suspended hundreds of feet above the street, the electricians, crane operators, and site supervisors left no monuments behind. But their innovations became the foundation for modern construction. Every system, every planning method, every logistics approach that allows modern buildings to exist began with what they figured out on a Manhattan lot in 1928. If this is the kind of story you want more of, like and subscribe and tell me in the comments which construction process you want me to bring to life next.